Hi Senior Stage, this is JP. Hope you guys are well and welcome to this lesson. We're going to look and be a bit critical about algebraic expressions. So you've completed the activity of topic 5, hopefully before you've watched this video. If you haven't yet finished it, please finish it now and then just come back to the video. Okay, so I'm just going to go through this. So in part A, I've asked you, okay, so you know that 3x squared, all square, can be written as 3x squared times by 3x squared, right? That's what that exterior exponent, of course, means. That means there are two of those brackets multiplied to each other. And then what we've got is we've got 3 times by 3 is 9, and x squared times by x squared is x to the power of 4. And then a quick way to get 9x to the power of 4 is to multiply the exterior exponent to the interior exponent. In other words, if I would multiply, so 3's exponent there's no exponent because there's a 1, we're just too lazy to write it. I mean, you don't, if I ask you how many friends do you have, you're not going to say you've got 6 to the power of 1 friends. I mean, it's not wrong, it's just a bit weird. So what you're going to do is you're going to multiply that exterior exponent to each of those interior exponents. Okay, so you've got 2 times by 1 and then 2 times by 2. So that means it's 3 to the 1 times by 2 and x to the power of 2 times by 2. And then 1 times by 2 is 3 to the power of 2 and 2 times by 2 is x to the power of 4. And 3 to the power of 2 is not 6. Be careful. It's 9. So then it's 9x to the power of 4. So that's the same answer, right? And is this just a fluke? No. So that's what you can do. You can multiply the exterior exponent to each of those interior exponents, not to the number. Please note that we didn't multiply the 2 there, the 2 to the 3. We multiplied 2 to 3's exponent, right? We multiplied the exterior exponent to each of those interior exponents. Let's look at another example. So here we've got 2x cubed y squared to the power of 3. So what we're going to do is we're going to multiply 3 to each of those interior exponents, and 2 doesn't have an exponent, but of course it's got an exponent. It's the exponent of 1. In other words, we're going to go 3 times by 1, 3 times by 3, and 3 times by 2. So we've got 1 times by 3 is 3, so it's 2 to the power of 3. Do you follow? X to the power of 3 times by 3 is 9, and then lastly we've got y to the power of 6. Do you follow? 2 times by 3. And then 2 to the 3, also it's not 6. 2 times 2 times 2 is 8. Yes, there we go. So we've got 8 x to the power of 9, y to the power of 6. That is, of course, exactly the same as going 2x cubed y squared times 2x cubed y squared times 2x cubed y squared. And let's check it out. So what we've got is we've got 2 times by 2 times by 2. 2 times 2 is 4, times by 2 is 8. And then what we've got is we've got x cubed times x cubed times x cubed. How many x's are multiplying together? Well, 3 from the first part, x times x times x. Another x times x times x, another x times x times x. How many x's in total? X to the power of 9, right? Not 9x, right? 9x means like you've got 9x girlfriends or boyfriends or non-binary friends, and in this case they are multiplied together, right? And lastly we've got y squared times y squared times y squared, and how many y's am I talking about now? 6 y's, right? 2, 2, 2. Okay, so that's exactly the same answer. Okay, then I ask you to multiply those expressions together. So, in other words, just to simplify it, in other words, the first one is going to be 2 to the power of 1, x to the power of 1, y to the power of 2. So if there's no exponent, it means there's an exponent of 1. Why don't we write it there? Because we're lazy. So, and that is, of course, not what's happening. There's an exterior exponent of 4, and we're going to multiply the 4 to each of those terms. So in other words, we're going to get 1 times by 4 is 4. We're going to get x to the power of 4, and we're going to get y to the power of 2 times by 4 is 8. Right, hopefully that makes sense. 2 to the power of 4 means 2 times 2 times 2 times 2, okay? 4 times. So that is equal to 2 to the power of 4 is equal to 16. and then we've got x to the power of 4, y to the power of 8. Okay, next one, multiply the exterior exponent to each of those exterior exponent. So it's x to the power of 4 times by 3 is 12. Okay, 3 times 4 is 12. And then 3 times by 5 is 15. That's all there is to it. Next one, xy all square. So x to the power of 1 and y to the power of 1. You multiply the exterior exponent to each of those interior exponents. So it's x to the power of 2, y to the power of 2. Easy as cake. Alright, next one, 2xy all square. So that means 2 to the 1, x to the 1, y to the 1, all to the power of 2. So that means you multiply it to each of those interior exponent, 2 to the 2, x to the 2, y to the 2, and that of course is equal to 4x squared, y squared. Right, 2xy times 2xy is 4x squared, y squared. Okay, then it seems like if I'm asking you some weird questions along the way, yeah? I'll take that. So what is 3 times by 2 all square? That is equal to 3 times by 2 is 6 square, and 6 square is equal to 36. And what is 3 plus by 2 square? That is equal to 5 square, and 5 square is equal to 25. Quick note, if I multiply the exterior exponent to each of the interior exponents in the first one, okay, so then you're going to get 3 to the 2 times by 2 to the 2. 3 to the 2 is 9, 2 to the 2 is 4, 9 times by 4 is also equal to 36. But let's look at the next one, 3 plus by 2 all square. If I now went like, if that's the above one, that's the above one, 2 to the power of 2, 3 to the power of 2, and 2 to the power of 2, 9 plus by 4, 9 plus by 4 is definitely not equal to 25. So we cannot do that. We cannot multiply the exterior exponent to interior exponents when there's what? What's the big difference between question 5 and 6? Well, question 5, it was all one term, right? It's a 3 times by. Question 6, there's a plus separating them. So you can only do it when there's one term. Let's go through it. Part B. Okay, so let's look at this. Let's look at expressions like x plus y square and 2x plus y square. I ask you now, I kind of gave it away now. Is x plus y all square equal to x squared plus y square? In other words, if I go x plus y times by x plus y, is that just equal to x squared plus by y square? No way, Jose. Because what happens? If you've got x times by x, that is equal to x squared. X times by y is xy. Y times by x is yx, xy. And what is y times by y? Y squared. Okay, are there any like terms there? Yes, xy plus xy. That is therefore x squared plus 2xy plus y squared. Right, and that of course is not equal to that. There's that middle term missing, the 2xy is missing. Let's look at the next part. So 2x plus by y all square means 2x plus y times by 2x plus by y. So if I multiply that out, if I expand it, 2x times by 2x is equal to 4x squared. 2x times by y is equal to 2xy. Y times by 2x is equal to 2xy. And y times by y is y squared. Are there any like terms? Yes, there are. 2xy plus 2xy is 4xy. So it's 4x squared plus 4xy plus y squared. Alright. Yes. You guys getting it? No questions? Do I see a hand? No. No, you can't go to the bathroom. No. Okay. Let's look at question. Okay, so is x plus y all square equal to x squared plus y squared? And is 2x plus y all square equal to that? No ways. There's a middle term that's missing in each of those cases. Do you see that first term? You can square the first term and the last term, but the middle term, it's just not there. How would you know if they are equal? Okay, well, you bloody well multiply them out. So if you multiply them out, if it's equal to x squared plus y squared, well, that's the case. But it's not the case here. Well, another way to know is if you make if you let x be a number, for example, x is equal to 2, and you say, for example, y is equal to 3. Let's see what happens then. So you're going to get x plus by y, right? So x is equal to 2 and y is equal to 3. Do you follow? You just substitute x into x, y into y. And you say, in this case, exactly the same thing. X squared plus y squared. X is a 2 and y is a 3. Right? What is 2 plus by 3 all square? That is 5 squared. That is equal to 25. And that is 4 plus by 9. Is 25 equal to 4 plus by 9? Is 25 equal to 13? No, that just sounds like very hectic accounting. So it's not equal. Alright, so that is another way to show it. You'd show it by substitution. Similar to the other story, again, if x is equal to a number like 1, y is equal to 2, you can, for example, show that 2 times by 1 plus by 2 square is not equal to 4 times by 1 square plus by 2 square. Hopefully I'm not doing this too quickly. Oh, am I? So what you just show that if you substitute a value x into x, oh no, that's not x into x and y into y, that they are not equal then, in other words. So 4 plus by 4, 16 is not equal to 8. All right, good. So part C. Simplify the following expressions. So what will you do there? You'll just multiply the living bits out of this. So in other words, x plus by 2y times by x plus by 2y. What you're going to do, you're just going to expand it. Expand. So x times by x is x squared. X times by 2y is 2xy. 2y times by x is 2xy. And 2y times by 2y is 4y squared. Okay, are there any like terms? Yes. 2xy plus 2xy. Yes. So it's x squared plus 4xy plus 4y squared. Next one. So, in other words, in question 9, could we have multiplied the exterior exponent to each of the interior exponent? Is this then equal to x squared plus 4y squared? X squared plus 4y squared. Yeah, well, those two, they are in it, but we're missing a middle term. So what do we need to be careful of here? If two terms are added, if there are two terms, if there is a plus or minus between them, you cannot square the first term and the last term. Thou shalt not square the last term and the first term if there is more than one term. Remember, that's the 11th commandment. Very important. It's universal interfaith. So let's go. Question 10. 4x squared y all square. How many terms are there now? There's only one term because it's 4 times x squared times y all square, right? So what we've got is we've got 4x squared y oh, no, you don't. Square. And what we do is we multiply that exterior exponent to each of the interior exponents. Please don't be strange multiplying to the actual numbers, the coefficients, to the interior exponents. So it's 4 to the power of 1 times by 2 is 2, x to the power of 4, y to the power of 2. Right? And what is 4 to the power of 2? Not 8, says 16. X to the power of 4, y to the power of 2. Alright. Question 11. What's that question? Someone's asking a question? No, you can't go to the bathroom. Just sit still. We're almost done. I'm almost done. Okay? Just focus. Last bit. 3x plus y all square is then 3x plus by y, 3x plus by y. So you're just going to expand that. 3x times by 3x is 9x squared. 3x times by y is 3xy. Y times by 3x is 3xy. Y times by y is y squared. Are there any like terms? Yes. Oh, no. What did I do? 3xy plus 3xy is equal to 6xy. So we've got 9x squared plus by 6xy plus by y squared. Alright, so just to conclude, when can I multiply that exterior exponent to the interior exponents? When? You say it quickly. When you have? Yes, one term. When there's no pluses or minuses between them. In other words, I could do it in question 10. I can multiply the exterior exponent to the interior exponent because there's only one term. There's no pluses or minuses between those variables, right? It's one term. If there's more than one term, thou shalt not multiply the exterior exponent to the interior exponent. You'll develop diarrhea, and remember there's no toilet paper around.